Welcome to the Pod-Key summary of SwiftData Group Lab from WWDC 2026. A lot of the interesting SwiftData questions right now are less about Hello World code and more about what happens when the app gets complicated. Shared stores, widgets, CloudKit, huge datasets, migrations, concurrency, and the little practical patterns that keep the whole thing from getting weird at scale all came up here. And the nice through line is that most of the advice is pretty grounded. Keep ownership clear, fetch less, test old stores, and don't ask lightweight processes like widgets to do heavyweight jobs. On multi-process setups, like a main app plus a widget or an app intent, the recommendation is to pick one process as the first among equals. That process owns the database, handles migrations, and basically acts as the adult in the room when store coordination matters. The sample trips demo uses a shared app group container, so the app and widget can both read and write the same Swift data store. But migrations are intentionally left out of extensions, which is a pretty clear signal. If the schema needs upgrading, send people back to the main app instead of hoping a widget can sort it out in passing. For large datasets, the recurring theme is to stay disciplined about what you load. Index the right rows, use fetch limits aggressively, and don't casually hydrate hundreds of thousands of records into memory if all you needed was a slice. If you're storing big binary data, SwiftData's external storage attribute helps by pushing those blobs out to separate files instead of bloating the main store. And for ingestion, batch inserts with short-lived model contexts are the safer move because they keep the in-memory object graph from ballooning while you import. There was also some practical advice around previews and testing that feels easy to overlook until it saves you. Preview traits can inject expressive sample data, including awkwardly long names and more varied sets, and you can even run a query inside a preview to drive the actual view hierarchy. For migration testing, the advice is to keep a corpus of legacy stores around, so every historical model version can still be exercised. That's the kind of maintenance job nobody is thrilled about until release week, when suddenly it becomes everyone's favorite idea. They also mention using AI-generated sample data to quickly fill out lots of model instances, which is handy if you need volume fast. If you need observable fetches outside SwiftUI View Lifecycle's ResultsObserver is the cleaner fit. It gives you query-like performance in places like view models without making you manually juggle notification plumbing. HistoryObserver is a different tool entirely. It lets you replay changes between two timestamps, which is useful for syncing to a remote server or replicating a store without listening to low-level core data notifications yourself. And if you want grouped results, both ResultsObserver and the newer Query API support section by key paths. So section lists can happen without manual post-processing. Sample trip shows that by grouping trips by destination, which is exactly the sort of thing you'd rather the framework calculate for you. One notable gap is aggregate functions. SwiftData still doesn't have built-in SQL-style sum, average, min, or max the way core data can. So today, you either materialize objects in RAM or fall back to a core data stack for those calculations. The team's message there was basically, send feedback with concrete use cases, because future API design is going to depend on real-world examples, not abstract wish lists. For non-optional model attributes, the rule is simple but important. Set them in the initializer before the object is persisted. And in SwiftUI, don't build a screen around an empty list fallback if the UI really depends on one root object existing. A better pattern is to fetch one object with a limit of 1, create it if it's missing, and only then present the view. Counting has a similar theme. Use fetch count on the model context instead of materializing objects just to learn how many there are. If views keep invalidating and causing too many refetches, the advice is to inspect it with SwiftUI and persistence instruments, break big views into smaller subviews, or use ResultsObserver, so refresh timing is more under your control. Adding an app group container after you've already shipped takes a little care. You can't retroactively have entitlements remap the old database location, so you need to copy the existing store into the new shared directory. On CloudKit, all apps sharing an app group need identical CloudKit entitlements if they're going to share that sync store. If they don't, or if the widget really just needs a timely local snapshot, the better move is often a separate local store for the widget. Widgets also don't get enough background time for full CloudKit sync anyway, so keeping just the locally shared data in the app group container can make the widget update when people expect it to, instead of whenever the cloud feels inspired. During development, schema alignment matters a lot too. If multiple apps write to a shared CloudKit container with mismatched schemas, you can end up with duplicate or conflicting records. So testing includes flipping all participating apps to production schemas together and verifying migrations line up cleanly. If you need to introduce version schemas after launch, the path forward is to treat the current schema as your baseline version and then define later versions incrementally from there. That lets you start applying migrations without breaking existing users. And if an app tries to open a store with an unversioned schema, that throws an error you can catch, which gives you a place to decide whether to show migration UI or prompt the user to open the main app. There was also a hint that migration progress could potentially tie into Foundation's Progress API someday. But right now, that would need a feedback report. On multiple model contexts, the guidance was pretty moderate. They're useful for independent transactions, and each context commits as a single atomic write. A SQLite is still basically one writer with many readers, and on low-power devices, too much concurrency just runs into I/O bottlenecks. So the advice is to keep active context to maybe 2 or 3, then benchmark with the I/O instrument, instead of assuming more parallelism means more speed. That caution also shows up with model actors, because SwiftData model objects are reference-based classes and they are not sendable. You can't safely pass them across actor boundaries, so the pattern is to send primitive data instead, like persistent IDs or dictionary-style deltas, and accept the serialization overhead. For list performance, a fetch limit often solves more than people expect. Sometimes pulling the top 1,000 gets rid of the hitching and makes explicit pagination unnecessary. If you do need paging, a lazy stack with a spinner at the bottom that triggers the next fetch when it appears gives you that smooth, infinite scroll feel. And for custom backends, SwiftData doesn't have to mean CloudKit or nothing. You can build a custom JSON store that conforms to the store protocol and use SwiftData's query layer on top of it. For systems like Firestore, SwiftData can sit locally as the cache, while history tracking drives incremental sync to the remote backend. One last useful detail. Enums with associated values can be persisted directly if they conform to codable using the .codable attribute macro. That works well when persistence is the goal. But if you need to query or sort on the underlying values, the recommendation is to model each enum case as its own entity with relationships instead of hiding everything inside an opaque blob. A lot of this adds up to the same lesson. SwiftData can do quite a bit, but it rewards being explicit about ownership, boundaries, and what actually needs to be loaded or shared. Which is maybe not the flashiest takeaway, but it is the one that keeps future you from opening instruments with a sigh. This episode was generated by Podkey. Create your own at podkey.fm.